Todd, we've talked to a number of scientists so far, and it's clear that to believe in the Genesis paradigm, as opposed to the conventional paradigm, puts you in a minority. And that means that it's probably tough along the way. And so, what is it about the Genesis paradigm and the data and the evidence that you see around you that causes you to continue to hold to that in the midst of a whole flow of things trying to pull you another way?
It works, and it keeps working. That's what keeps impressing me. It keeps dragging me back, even when I think, well, maybe I should not bother. I keep finding new ways of understanding things, new insights into nature. I mean, this is what science is supposed to do, right? And for me to read through Genesis and see how integral it is to the basic Christian story of creation, fall, and redemption, I don't think that we can just reimagine all that. And then when I go and think about what kind of scientific insights that I can gain from that, it continues to impress me how much progress we're making. If creationism is so bad and so wrong, why is it we keep making progress? Why do we keep, even geology and the biology, the whole 9 yards, all of it? It seems like we're continually finding new insights and new ways of understanding things. That suggests that we must be on the right track, I think.
So this is not just a blind faith for you. I mean, this is something that you see substantiated everywhere you look.
No, I don't think it's a blind faith. I'm not even sure that I like that phrase. I mean, it implies that, there's just nothing there. I'm just going to believe for no reason. But I also don't want to underestimate the open questions. There are a lot of hard problems that creationists still have to sort of resolve. But the fact that with so few of us, we keep finding new ways of thinking about this problem and that problem, that's like, I'm on a long journey and I'm not to the city that I want to get to yet, but I keep passing those signs that tell me how many miles I got to go, which is pretty exciting. That tells me I'm on the right track. I'm going the right direction. So that's the way I look at it. I just find it really exciting, even though I might not have all the answers that I'd like to have yet.
Well, that seems to be the kind of the characteristic that we're seeing of the creationist scientists that we're talking to, that there's an underlying confidence there that the scripture is right.
Absolutely, yeah. The more I dig, the more I work at it, the more insight I get, the more answers I get. It's really exciting. It's really exciting. Mm-hmm. I can't imagine why, young science students wouldn't want to do what we do. I mean, it's some of the coolest research that you can possibly imagine.
But there are still these great questions to be answered, and you're looking at the zebras, and they're all unique, and yet all of these creatures are just so much complexity and diversity. How does the standard story, the conventional paradigm, explain all of that?
Well, they would use evolution, right? So millions of years, random variations, all things that are alive now, that cactus, that zebra, the grass here, it's all related. We all go back to a common ancestor that lived billions of years ago. And through the process of mutation and genetic variation and natural selection, that's where we get the stuff that we have today.
But doesn't that imply that all of those mutations are positive? They're all moving towards all of this diversity that we have?
Well, there certainly has to be a lot of beneficial mutations. There can be bad stuff. I mean, that's what natural selection is going to get rid of, because natural selection is basically killing off the stuff that's not fit to survive. So anything bad that crops up is going to be presumably eliminated by natural selection. So there can be bad mutations in the conventional model. But yeah, you got to have good mutations too to make the variety of things that we see. You've got to have a lot of really good stuff that happens in the history of mutation.
Mm-hmm. Does that seem reasonable?
Well, that's a good question. I mean, from what we can see in genomes today, we can see, there's some mutations that might be helpful in some circumstances. Other mutations are probably not so good. But the vast majority of them, they don't do anything. They're just useless. And so, we all have to think about mutations because when we can look inside of a created kind, we can see differences in genetics. So, creationists need mutations too. The real question is, what kinds of mutations are happening. So in my view, it's not a random mutation. Just randomly changing any part of the genome is probably not going to do much of anything, really. What we need are mutations that are helpful and beneficial, but those are the kinds of things that can only be built into the system. Evolution needs mutations that produce an external feature that can be selected, right? That can alter the survivability of the organism. And sometimes that happens, sometimes it doesn't. The vast majority of times, there isn't going to be any external feature that you can select for.
So we're kind of talking about how random mutations can produce such exquisite design.
Yeah, in some sense it is. It's not just mutation, because you got selection going on there too. So you do have features that are clearly well designed for the environment. So right over here we've got these oryxes, right? Beautiful, beautiful creatures, and very, very pale colors. The wild range of the oryx is right on the southern end of the Sahara Desert. And so you can see, yeah, their coloration makes sense. Natural selection, if you get a really dark colored one, that's going to be really easy for predators to find. And so they end up being these really beautiful light colors. And that's an example of where selection would take a variation and turn it into an adaptation.
And that brings us back to the notion that a really exquisite design in the beginning
I think so. Oh, absolutely.
Has provided these creatures with the ability to survive and to change for their benefit.
Absolutely. So the ability to be able to change your coloration like that, to be able to fit an environment, that's got to be built into the system before it starts. As I said, random mutations, they generally don't do anything. So it's hard to imagine how you're going to get a lot of random mutations that are going to actually produce just the right coloration for the environment that you're living in.
What about the issue of natural selection, though? Does that have the power to get us to where we are?
That's a hot area of research. Lots of people looking into that. And what we find most often with natural selection is that natural selection does a lot of fine-tuning. Natural selection is basically all about killing off things that aren't fit for the environment. So if you're a finch in the Galapagos and you have a really tiny beak and the only food available to you is really big hard seeds, you're going to die. And that's exactly what we observe. And so we can watch over the generations as the beak size of finches change in the Galapagos. But they're still finches, they're still birds. The notion that natural selection can generate all of the diversity we see, that's not been demonstrated.
But that natural selection, is that working within the kinds, or does that allow us to go beyond that?
From my perspective, most of the examples of natural selection are working within the created kinds, right? And so, now don't get me wrong, I mean, natural selection and random variation can do amazing things. I mean, it's pretty astonishing the kinds of changes that we can see. But no, they don't change from one kind to another. We have not observed that. All we've observed are the kinds of changes within populations that happen. Not even, across species, mostly within populations. So it's very small stuff, and that's why I call it fine-tuning, because it's mostly taking one group of critters and making sure that they're really fit exactly for the environment where they're living.
Natural selection, then, obviously exists. We see it around us. We see it in the fossil record. Have you pondered and thought about what God was doing when He created all of this that gave the potential for natural selection to occur?
Natural selection is sort of an inevitable part of the world. If you have random variation and things can die, then there's going to be natural selection. So before the fall, I would say there's probably no natural selection going on in the animal world, at least. But then after the fall, it serves as that fine-tuning feature, right? So it makes sure that the population of animals still survives, even though the environment's fluctuating and changing. It's just an inevitable kind of thing that you have to have in a world that is changing all the time. And, the flood is coming. God knows this at creation. So, yeah, there's this system in place already, not just to allow variations to come out of animals, but for even the most careful adjustments to make sure that populations don't just crash and die, go extinct.
So the tree of life that we see in the textbooks, that is a picture that everything started from one thing, and all of this diversity and exquisite beauty that we see came from that one trunk, so to speak.
So you're right. I mean, evolution would say there is only one tree, and it all goes back to a single common ancestor, which is, you know, the base of the tree. But I would say, no, there's actually multiple trees. There's a felid tree, which has all the cats on it. There's the canid tree, which has all the dogs on it. There's the ursid tree, which has all the bears on it. There's the equid tree with all the horses on it, and so on and so forth. Each individual created kind, then, has its own individual tree, so that what you end up with is not one big tree of life. You end up with something like an orchard or a forest, where you have lots of different trees all growing together from the same created base.
But this forest has trees that have a lot of branches on it, and that's that each kind now branching out into all of these different species that we see.
Yeah, absolutely. So, you know, they all start at creation, right? So they have that common beginning, but they're individual trees. So they're not all related to a common ancestor. They're all related to their own individual common ancestor. So the cat ancestor and the horse ancestor and whatnot. And so then they diversify over time, especially after the flood, when you have this period of massive upheaval when critters can change all over the place.
And is that what the data shows us?
I think so. I would start with what I read in Genesis, which tells me about, you know, at the end of creation week, you have all these different creatures already there. You have flying things and swimming things and creeping things. And when I look at the data of nature, I see both similarity and difference. So an evolutionary biologist would say, look at all the similarity, and that puts everything on a common evolutionary tree. And I would say, yes, there is similarity, but there are also significant differences. And the significant differences, and this is really important, they end up exactly where I would expect them to. So I look at the Bible and I see flying things, swimming things, that sort of thing. Those are really big categories. I don't see it mentioning individual species. You read through Genesis 1 and 2, you won't see lions and tigers and things like that. So it's got to be somewhere between, you know, bird and the individual species of bird. That's where I would expect to find these differences. That's where I find them, over and over and over again. It's astonishing. And so, you know, I shouldn't be astonished, but I am. It always delights me when I think, hey, the Bible works. What do you know? But that's exactly how it works in this situation. I find these differences that essentially make sense of exactly what I'm seeing in the scripture. I'm seeing those differences right there where they should be.
As a scientist, looking at all of this data and everything that you see, it seems what you're saying is that the Genesis paradigm answers all of this data better.
Yeah, I think so. I mean, ultimately I think it does, because it embraces both similarity and difference. Now, as we've already said, there's lots of questions that are still out there. But I'm pretty confident, given what our paradigm can explain, I'm very confident that those answers are going to be found.
But in this single tree of life, in the conventional paradigm, if that were true, then we must have all of these transitional forms between kinds.
Yeah, so that's a good question. So there are a lot of critters out there, especially in the fossil record, that are put forward as these things they call transitional forms. I like to call them intermediates. I like to just think of them in terms of the qualities that they possess rather than whether there's some sort of transition. And in my view, based on my years of study, I see two kinds of intermediates. I see intermediates that occur within a created kind, where I can say, oh yeah, this is this created kind. And then I see intermediates that appear to possess traits of more than one created kind. So actually I have right here in my backpack one of those sorts of transitions. So this is a mesohippus. Okay?
You have to explain that.
Very small, right? But this is a member of the horse kind. And if you've ever seen a horse without its skin on, you'd say, oh yeah, that looks just like a horse. But that's not enough for a scientist. You can't just go on, oh, it looks like a horse. You got to do some statistical analysis. And I've done that too. So I've used characteristics of the skull and the teeth here to show that, in fact, yes, this is a horse. It fits in the horse created kind. It is not something else. It is definitely a horse. So this thing is supposed to be one of those transitional fossils as horses are evolving from their tiny little ancestors. I mean, what I'm seeing here is really just another version of a single created kind. Yes, it's a horse, and yes, it's different from the horses that we have today, but the transition is only within the created kind. Now, there are others, as I said. There are intermediates that appear to possess traits of more than one created kind, but we'll have to go over to the birdhouse to check those out.
Okay.